is example number 5 in the 9B notes. And guys, this is the chart that we filled out when we were doing example number 2. But I wanted to remind you guys that when we're filling these charts out, I want you to bring these categories. This vanilla means that all of this branch is representing the vanilla cupcakes. Okay? That branch are just vanilla cupcakes. And what's really important to remember is that 90 just means, well, there's 90 vanilla cupcakes. But of those vanilla cupcakes, we have some of them that have blue frosting. Okay, so these are vanilla cupcakes with blue frosting. These are vanilla cupcakes that have pink frosting. Okay, CC is for cupcakes. Now, 120 means, well, wait, we have more than just 90 cupcakes. That's because we also have a chocolate branch. Okay, so this whole branch over here are just describing how many chocolate cupcakes we have. Okay, and I always tell you guys, make sure to put the labels on those bottom numbers. It's so much easier to keep everything straight if you label these bottom numbers. That's because these bottom boxes or the bottom numbers at the bottom of a tree diagram, that's the only actual thing we have. The other boxes are subtotals of what's down here. But these are the actual items in our sample space. Okay? So we have 90 vanilla cupcakes. Here is just reminding us all the vanilla cupcakes added together is 90. But here, 30 of them are with blue icing, 60 of them are with pink icing. Okay? Here's our chocolate cupcakes. We've got 10 of them that have blue frosting and 20 of them with pink frosting. This box is just saying, well, when I add up the two different boxes below me, it makes 20. And then up here, it's saying, well, if I add up my vanilla ones and my chocolate ones, I get 120. And remember, this is our big total. And when we're finding probability, we're always looking for the number in the category we're finding probability for. This is also called our specified outcome, right? Or our desired outcome. Okay. And then on the bottom of our fraction is always the total number in our sample space. Okay. That's our probability formula. Okay. So what we're going to do now is we're going to go over to our question pieces and just work through this problem. So the first thing we're going to look at is the probability of chocolate. Now remember, some of our cupcakes are vanilla cupcakes, some of them are chocolate cupcakes. And probability, we need to find out how many are in this category. Well, that's pretty easy because all of the chocolates are subtotaled here. So we know we've got 30 chocolate cupcakes. And we know our big total is 120. So that's easy to find. What about the probability of pink frosting? Well, we don't have a pink frosting branch like we did with the chocolate. So we need to make our own pink frosting category. So let's look at what parts of our data represent pink frosting. Okay? Well, the only parts of our data that represent pink frosting are these two. We have some chocolate with pink frosting and some vanilla with pink frosting. So the chocolate with pink frosting, we have 20. And the vanilla with pink frosting, we have 60. So when we're finding our pink frosting total, we just add these together, right? And that's going to give us 80 that have pink frosting. Okay? So we know that when we do our probability, since we figured out how many have that pink frosting, these guys together make 80. Our probability of having a cupcake with pink frosting is 80 over our big total, 120. Okay? What about the probability of being a chocolate cupcake and pink frosting. Now remember, and is where it's a subset. The items in there are both chocolate and they have pink frosting. So it's a smaller subset, right? Because they have to be chocolate and they have to have pink frosting. So the only cupcakes we can look at are these guys. These are the chocolate cupcakes with pink frosting. So when we are getting our probability for that, we're just going to take the number in that category, which is 20, and put it over our big number, 120. All right, well now part number 4 is saying, is having a chocolate cupcake and pink frosting dependent or independent? And whenever we're answering a question like this, we're going to remember that when we're looking for whether or not two different events are dependent or independent, we use the formula. And we always are asking, do the two sides equal? Are they equal? If they're equal, then the two events are independent. If the two sides are not equal, then the two events are dependent. Okay? So we're always going to set up a formula and plug in the numbers that are specific to our problem. Okay? So here I've prepared a little template that's based on our formula to find independence. And we're just going to plug in the numbers that we've already found that go with each part of our formula. So again, we need to look at the probability of our first event. And in this problem, the first event is the probability of being a chocolate cupcake. Well, we already found that, right? So the probability of being a chocolate cupcake is 30 over 120. What's our second event? What's the probability of a cupcake having pink frosting? Good deal, we already found that. And now remember that these are multiplied together. I'll write it a little bit neater. And then we're asking, is it equal to the probability of being a chocolate cupcake and having pink frosting, which again, we've already found. So now we've filled in all the parts of our formula for determining independence or dependence. And what we need to do now is we need to simplify the sides, okay? We need to multiply these two fractions together, right? And find the decimal, okay? So that's what we're going to do. We're going to multiply these two together and find a decimal. And when we multiply them together, remember when we're multiplying fractions, we're always multiplying the top numbers and then multiplying those bottom numbers, okay? So let's go ahead and do that. When we multiply the top numbers, we take 30 times 80, and that gives us 2,400. Okay? And we're going to put that over 120 times 120, and that's the same as 120 squared, right? When anything times itself. And we'll get 14,400. And we're trying to figure out, well, does that equal 20 over 120? Well, these numbers, these fractions don't look at all alike. But you know what? This isn't the best way to find out if they're equal because these fractions are not simplified. And fractions can look different if they're not simplified. So let's go ahead and divide the top by the bottom and get a decimal for each one. So when I divide 2,400, that's the top number for this guy, by the bottom number, 14,400. Oops, too many zeros. 14,400. I'm going to get what? What's that? Oh, I cleared it all out. 2,400, one more time, third time's the charm. Now, we get a big decimal here. And remember, we're rounding to 2 places past the decimal. So we have to look at the third digit. If it's 5 or above, we're going to bump this second digit up 1. If it's 4 or below, we're going to leave it alone. So since this is 6, this is going to become 0.17. Okay? What about this guy? Well, let's go ahead and do 20 divided by 120. What's that going to equal? Oh, doesn't this look familiar? Again, we're rounding to 2 places past the decimal. That third digit's a 6, so we'll round up. And that'll give us 0.17. Look at that, guys. We can see that 0.17 is equal to 0.17. So if the 2 events are equal, then A and B are independent. And that's how we work these independence problems. Thanks for watching, guys.